Swayam Prabha. Digital India. Educated India.
Welcome back to the course Geology and Soil Mechanics. So, in the last lecture we just talked about different types of stresses, in situ stresses, right, and there we have cleared our conception regarding the total stress, effective stress and the pore water pressure, which are related. Okay. So, that means if you know the total stress, if you know the pore water pressure, you can find out the effective stress, which is nothing but the stress which is getting developed at the contact point of the soil grains, right. Similarly, if you know the pore water pressure as well as the effective stress, you can find out the total stress. So, these relations already we have seen, and we discussed and we derived the equation or the expression of the effective stress, and we have seen that the effective stress at any point is independent of the depth of water, okay, above the submerged soil. So, if you have the submerged soil or the saturated soil, right. So, basically the effective stress is not dependent on how much water you have on top of the soil deposit. So, that is completely independent of that kind of water level or the water depth. So, effective stress is basically the sole property of the soil grain contact point stress, right. So, now we'll be seeing that if you have the saturated soil, and if you want to find out the stresses developed in the saturated soil, and there is no seepage happening in the soil deposit or the soil sample, then how we can find out the different component of stresses. Now, let us see this problem. So, in this problem basically you have one soil, this is the soil deposit. So, this is your soil deposit and you are connecting one pipe. So, this is your connecting pipe. Okay. Initially, it is the valve is closed. So, that means initially you are saturating the soil and the actual water level is here. So, this is your actual water level, and once it is reaching there, you are stopping the valve. So, you are closing the valve. So, that means the small h1 is the depth of free water, which is lying above the top surface of the soil deposit or soil sample, and H2 is the depth of soil sample or the soil specimen. So, because of this, there is no water flow, actually the flow is not happening. So, the soil deposit as well as the water is in the stagnant phase. So, that is why you will be getting the same level of water at each and every location in the soil sample. So, now in this situation I would like to find out the stresses. Okay. Let us see how we can find out the stresses at different location. Now, first for example, if we consider the point, the top surface, that is the surface here, at that time what is the total stress? The total stress is 0, right. So, there is no issue for that. So, and then what is the pore water pressure at that location? Of course, the water head is not there. So, that is also 0, and eventually you do not have effective stress concept, because the soil grains are not occupying the top surface of the assembly. Okay. So, that means at top point you are having total stress 0 as well as pore water pressure 0, whereas there is no information about the effective stress, because effective stress is the sole property of the soil grain, as I told you. Now, if you travel from the top surface to the depth say h1 and you come to point A, say. Now, at that point what will be the total stress? Total stress will be h1 into gamma w, am I right? So, that will be the total stress, because still you do not have any soil grain which will be giving you some component of the effective stress. So, the whatever stress is getting developed, that is solely due to the the free water which is coming on top of the soil specimen. So, that total stress is nothing but h1 into gamma w, and that is solely due to the pore water pressure. Therefore, your pore water pressure is also h1 into gamma w, whereas your effective stress is simply 0, right. So, I hope that you are following this thing, right. So, now if you travel from point A to point, say some point C, which is situated at some depth z from the top surface of the soil, okay, soil specimen. So, that means you are traveling to point C, which is having the depth equal to h1 plus z. So, that point. So, at that point the total stress will be h1 into gamma w because of the free water plus z into gamma saturated, right. So, your soil is completely saturated. So, z into gamma saturated will be your z equal to z into gamma saturated plus h1 into gamma w will be the total stress. If you try to find out the pore water pressure at that location, that will be simply h1 plus z into gamma w, because the water depth or the water level or the water table height is h1 plus z. So, the pore water pressure will be simply h1 plus z into gamma w. So, that you are getting here, right, and the relation is linear. So, of course, so you are connecting all the points with the linear line or the linear curve. Now, what about the effective stress? So, now you will be getting some effective stress, because now you are within the soil specimen, and so you can expect some effective stress which is getting developed in the soil matrix, right. So, the effective stress will be z into gamma prime. So, from our earlier discussion or the earlier knowledge, whatever we have discussed so far regarding effective stress, total stress as well as pore water pressure. So, effective stress will be z into gamma prime. How we can get it? So, we can simply get it the total stress minus the pore water pressure, that will give me the effective stress, right. So, similarly, if you travel to point B, okay, so at that time if you want to find out the different component of stresses, then at that point your total depth is h1 plus h2, okay, and you are getting the total stress as h1 plus gamma w due to the free water, that will be remaining constant, right, because you are not varying the depth of the free water surface, okay, during the say study. So, h1 plus gamma w plus h2 is the total specimen depth into gamma saturated, as we have done for point C, the same thing is coming here. So, h1 plus gamma w plus h2 into gamma saturated will be the total stress. Now, what about the pore water pressure at that location? That will be simply h1 plus h2 into gamma w. So, that is given here, right. So, if you subtract the pore water pressure from the total stress, you will be getting simply the effective stress, which is nothing but h2 into gamma prime, or that is nothing but your gamma submerged, right. So, if you do not have any seepage flow or the flow is not happening in the material, so that means everything you are saturating it and you are trying to find out the stresses under rest condition. So, there is no flow, no disturbance in the soil matrix happening. So, in that situation, so these are the different stress components, and in that way actually you need to find out the stresses at different location of the soil, okay, to obtain the information about how the stress zone is getting developed inside the soil deposit, right. Now, if we consider the seepage flow, now in the same problem, now if we consider the seepage flow, that means I am now opening the valve, instead of closing the valve, I am now opening the valve and I am allowing the water to move inside or to pass through the soil matrix, and it will come to the top surface. So, if it is happening, that means the upward flow, upward seepage flow, if it is happening, then how the stresses are going to change, that we will now see. Now, in the same problem, as I told you, now we are considering the upward seepage, that means we are opening the valve, that means water is moving upward, okay. So, in that situation, see at the head difference, so this is the top surface of the water, because after that water will be spilling out, okay. Now, the head loss happening for the water when it is traveling from the bottom surface to the top surface to this surface, say, that is happening with small h, right. So, that is your head loss. Similarly, at any depth z, your head loss is h by h2, that is a linear relation into z. So, that is the head loss, right, at different. So, if you consider, so this is your say initial head and this is your say final head. So, that is the head loss which is causing the seepage flow, which is causing the passing of the water through the soil matrix. Now, say now I would like to find out the total stress, pore water pressure as well as the effective stress under this kind of seepage flow or under this situation where the flow is happening in the upward direction. So, now we will like to see at different locations how we can find out the total stress. So, at the top surface the total stress will be 0. So, there is no issue whether it is whether seepage is happening or not, because you do not have any head on top of that, right. So, no stress is happening, no stress is acting at the top surface or the free surface of the water. So, that is 0. Now, what about the pore water pressure? That will be also 0, because there is no water level or the water depth on top of the top surface, right. So, that is also 0. Now, what about the effective stress? It is not coming into the picture at all, because you do not have the soil grain, okay, at the top surface, because the top surface is occupied by the water only. So, if the soil grain is not there, you cannot have the effective stress, because that is the property of the soil grain or the contact between the soil grain. Okay. So, now coming to point A, which is at H1 depth below the top surface. So, at that time what is your total stress? H1 into gamma W, as we have seen in the last problem also when there was no seepage. So, H1 into gamma W. So, therefore, your pore water pressure is same H1 into gamma W. So, therefore, your effective stress is 0 at that point. Okay. So, that means you are just on top of the soil specimen. So, your effective stress is 0. Now, if you come to some point C, okay, at that time what will be your total stress? Okay. So, C is located at a depth H1 plus Z from the top surface. So, that is here. So, your total stress is H1 gamma W plus Z gamma saturated, which was same. So, H1 gamma W is coming from the free water depth and the Z saturated, Z into gamma saturated is basically coming from the soil participation or the soil contribution. Okay. So, if you look at this problem and the previous problem, so then basically your total stress is not getting changed, that is remaining constant. That is the beauty, or that is the main important thing which I want to emphasize at this particular time. Okay. So, total stress basically that is remaining constant. If you recall, that was also in the previous case when there was no seepage, that I mean at that time also you were getting the total stress equal to H1 gamma W plus Z into gamma saturated, and during the seepage also you are getting the total stress at that at Z you are getting the total stress as H1 gamma W plus Z gamma saturated, same. Now, let us look at the pore water pressure distribution. Let us see what is happening at the pore water pressure due to the seepage. Now, in the pore water pressure basically, so basically H1 plus Z into gamma W, H1 plus Z into gamma W, that is nothing but the total pore water pressure at that depth, agreed. So, which we have seen in the earlier case also when there was no seepage. Now, because of the seepage happening, you are getting some extra stress or extra pressure which is happening at the water body, right. So, that is nothing but I Z into gamma W, right. So, I mean from your seepage knowledge, if you recall whatever we have seen in the seepage chapter, that what is the seepage force, you can calculate or you can find out the seepage force. So, the now seepage force, okay, or the pressure we can find out, and that is nothing but I Z into gamma W. So, that component is nothing but the extra component or the additional component, now it is getting added to the pore water pressure, agreed. So, now we can find out what is the effective stress. The effective stress is total stress minus pore water pressure, which comes to Z into gamma prime minus I Z gamma W. Now, what is happening? So, if you look at this, this is very interesting thing. What is really happening here? So, Z into gamma prime, that was the effective stress when there was no seepage, that you have seen in the earlier case, right. Now, you are getting the effective stress as Z into gamma prime minus I z into gamma w. So, this much the stress is getting subtracted from the effective stress due to the seepage only. So, if there is no seepage, whatever effective stress you are getting, now because of you are getting some seepage, your effective stress is going down or decreasing, right. So, you have to remember, or you have to be really careful when you are doing some design, okay, some geotechnical structure. If it is under some static water, right, there is no flow happening in the water, I mean soil body, then whatever effective stress you will be getting, okay, you may get some increased effective stress or decreased effective stress due to the direction of the flow, of course, that is true. Now, we are considering the upward flow, that is why you are getting some reduction in the effective stress. If it is the downward flow, you will be getting some addition, right. So, some additional effective stress. So, that, but ultimately your effective stress is going to be disturbed due to the seepage flow. That is the only important thing. Total stress, though, I mean if you look at or if you design the problem based on the total stress, that is not going to change, that already we have seen it, total stress is remaining same. Due to the change in the pore water pressure, you are getting the change in the effective stress, and so you must think about the effective stress when you are thinking of designing something. Okay. Now, similarly, if I come back to point B, okay, which is the bottommost point, at that time the B is located at H1 plus H2 from the top surface. Okay. At that time your total stress is remaining like that, which is same as before when there was no seepage. Now, your what about your pore water pressure, that is nothing but H1 plus H2 into gamma W plus H. H is nothing but the head loss, okay, H into gamma W. Okay. So, I into Z, instead of I into Z you can write down I into H2. So, I into H2 is nothing but small h, right. So, that is coming to the picture. So, that is your pore water pressure. Okay. Now, what about the effective stress, that is H2 into gamma prime, that was there earlier, right, minus this much H into small h into gamma W is the reduction happening in the effective stress. Now, we will see those things in the equation form, and we will try to find out or try to derive those things. Now, if water is seeping, the effective stress at any point in a soil mass will differ from that in the static case, right. Already we have discussed so far, I mean whatever we have seen, okay, in different problem when there is no seepage, when there is some seepage. So, depending on that, basically you are getting some change or the variation in the effective stress. Okay. It will increase or decrease depending on the direction of seepage. As we have seen in this case, when the seepage is happening in the upward direction, you are getting some decrease or the reduction in the effective stress, but if you have the flow in the opposite direction, that means the seepage or the flow is happening from top to down in the downward direction, then your effective stress will be getting increased, though your total stress will be remaining same, but because of the direction of the seepage you may get some decrease or increase in the effective stress. So, effective stress is very important. So, that means if you consider, I mean there could be a possibility that if you consider the downward flow, right, and if you try to increase the seepage, I mean this flow, I mean seepage pressure, right. So, that will basically